2.7 inverse trigonometric functions and functions differentiation. So we're going to do derivatives. Develop properties with 6 inverse trigonometric functions. Differentiate inverse trigonometric functions. And review the basic differentiation rule for elementary functions. We're going to go over all the differentiations. We're not really doing everything, but just show you. There's the last page, last 2 pages talking about all the derivatives for regular functions and all the derivatives for the what? Transcendent functions like log, exponentials, and trigonometry functions, all that. All right, inverse trigonometric function. None of the 6 basic trigonometric functions has an inverse function. That is correct. If you look at what? Entire domain.
Yes.
If I'm looking from negative infinity to positive infinity, no, you don't have inverse functions. Remember for example, sine function, what does it look like? It's a periodic function. It's periodic, right? Periodic means you go up and down, it is a pattern, right? So, no, it's not an inverse function because if I draw a line through, how many times does it go through?
Yes.
Infinitely many of them. You see what I'm talking about? So it's not a one-to-one function. But, so what we're going to do is, the statement is true because all the 6 trigonometric functions has what? It's a periodic and it's not a one-to-one. But this is what we're going to do. In this section, we will examine these 6 functions to see whether their domain can be redefined, which means what? We're restricting your domain. I'm not looking at negative infinity to positive infinity, but I'm going to just look at one period, one cycle, that's it. Then we have inverse functions on restricted domain. So I'm looking at the only small part of a domain, not entire domain. Are you with me? That is why you have an inverse function. For example, this is what we're going to look. I'm going to look at the sine y equal to x. I'm only going to look at domain to be this and range to be that. Did you see that? Now it's not negative infinity to positive infinity anymore. Are you with me? I'm going to make my domain small, one cycle. That's it. So, did you see that whenever you put arc, that means what? Inverse. Are you with me? Arc sine is what? It means what? Inverse of sine. Arc cosine means what? Inverse of a cosine. Whenever you see arc, means it's inverse. Okay, everybody with me? So, that's that. Now this is a picture so you can see better. So this is the inverse of a sine function. So when you look at the sine function, this is what a sine function looks like. So did you see their mirror image? If I draw a line here, they're exactly mirror image, isn't it? This is the y equal to x. So the red is the blue one that I drew, that's the sine function. So I'm only looking at the sine function from pi over 2 to where? Negative pi over 2. And then the y value should be like 1 to negative 1, okay? So let's just look at the inverse function only. Don't worry about the regular function. So arc sine, this is only I'm going to look at it. It's clearly, you can see this is one-to-one function. Is everybody with me? You draw a horizontal line, you draw a vertical line, they only pass what? 1. So this is a one-to-one function. This is a definitely one-to-one function. What about here? Yes. Is everyone is a one-to-one function? Even this one. Why? If I just look at over here, this only passed what? 1 time. Are you with me? Okay. So all these are one-to-one functions if I restrict my domain to whatever I want to look at. Here, negative pi over 2 pi, and this is what? Negative pi over 2, 0, and then 0 to what? Pi over 2. And for the domain, you go to negative infinity to where? Negative 1, and 1 to what? Positive infinity.
Yes.
Is everybody with me? Okay. All right, so they were asking you, evaluate each function. Arc sine equal to negative 1/2. So we can think of, if I give you, say, y equal to sine theta, okay? So now I'm gonna say, okay, if I want to do, what's the inverse? Whenever I put the inverse, what happens? I need to do what? Put the inverse to 2, so I can put, I can do that, right? If I do arc sine and sine cancel out, right?
Right.
And you get theta equal to what? Arc sine y, isn't that what it is, right? So you're telling me, arc sine negative 1/2, what does it give you? So you can just plug into your calculator, right? Arc sine negative 1/2. What is my theta? Tell me what that equal to. When does it give me? Yes.
How do we get to arc sine?
Invert, the second sine.
Second
Oh,
sine.
that's what arc, okay, I
You
thought,
see it?
Yes.
You see sine negative this?
Sine negative 1.
Okay.
Sine negative 1 is inverse, right?
Okay.
So your calculator will say what? Sine negative 1, sine to the negative 1, that means inverse.
I don't you gotta put the calculator in radians, right?
No, if I, no, I want degree. Give me a
Okay,
degree,
okay.
degree. So,
Negative.
your answer, what is it?
Negative 30.
Negative 30.
You got 5 negative 1?
Oh, my bad. Oops.
Is everybody with me? So this is easy problem because your calculator can give me whatever I need. So this case, what do you need to put?
Inverse cosine.
Yeah, cosine inverse 0, give me whatever the degree that is. You know what the degree is? 9, right? You know what to do over here? Tangent inverse 60.
Alright.
So,
Hold on.
17.4.
Let's go.
5.
Alright, let's see what you
So
got.
is everybody with me? This is the degree.
Mhm.
So just do, so this is just telling you, apply what? Your inverse to figure out your degree. Because if I give you this, if I say sine 30 degree, then you're gonna say, oh, that's equal to 1/2.
Right.
Remember? So if I wanna go back, say then what do you have to do? Arc sine 1/2, then what do you give you? 30 degree. Is everybody with me? The inverse relationship? Okay. So everybody with me now? Oh, plus sine unit. You guys came this day, the rainy day, definitely the sine unit, right? So I have that right here. All right, so they gave you pi over 6. That's your radian. If you want to give you pi over 6, that's fine. That's also what, 30 degree. Are you with me, class? So you can give me a radian, you can give me a degree. If you want to give me a radian, you need to give me in terms of a pi. Otherwise, give me a degree, 30 degree, 40 degree, whatever the degree. All right, just like we said, remember, they're inverse to each other, so when you composite them, they get a what? Equal to x. For this case, we are going to look at only this as my y, and that's to my x.
Okay.
All right, so remember this. I'm only looking at that from our arctangent. So when you do your problem, remember, mindful about your domain and range, because we're not looking at entire domain, entire range anymore. Our domain is restricted, so you have to be mindful, what am I looking at? What restricted area am I looking at? Are you with me, class? So do your homework, pay attention, whether that is in your domain. All right, if I give you this, what do I need to do? I'm looking for x. So it's arctangent, so I need to apply which one then? Tangent,
Tangent.
right? And apply what? Tangent here. Are you with me, class? Why did I apply tangent? So arctangent and tangent what? Cancel out because they're inverse to each other. Then I just simply have what? 2x minus 3 equal to tangent pi over 4. You know what tangent pi over 4? Just put in your calculator. What's that equal to? Is that 1?
Yes.
So we're gonna say so you have that, and you just wanna just simply what? Do the algebra. 2x equal to 4, then you're gonna say x equal to what? 2, then you don't.
Simple.
Which is simple, because your calculator gives almost every answer that you need to find. Arctangent or tangent, just simply plug it in. But in this case, you're getting a tangent of 45 degrees, which give you a 1. Pi over 4 is the same as 45 degrees, right, class? Pi is 180, so 180 divided by 4, which give you about 45 degrees. Here. Right with me? So is everybody good? Yeah.
Don't you have to like switch my calculator back and forth?
If you have,
Okay, you want this to be pi over 4, you can plug in pi over 4 if you want to. It knows what that equals, that should give you 1. Does not give you 1?
When it, like,
It's a degree,
because the other
so-
problem was a degree model, he gave me like a decimal, and then I had to switch it back to radian.
Okay, so you have to put it back in the radian, and it give you 1? Okay.
you got to switch it right.
All right. If you want to stay to radian, that's fine. We'll still get the right answer, by the way. Okay? It's just different, but you just have to say this is it, right, radian, yes.
When I put the other one in radian, it gave me a decimal instead of like power of C.
Yeah, because it does not know how to translate to a pi. Okay, you have to make it into, like, you have to multiply by 180 and give you whatever that number is, because pi is 180. Because remember, the entire circle is what, 2 pi. All right, what was it that I wanted to say? Remember that. Must be not ready. Okay. Derivative of inverse trigonometry function. I am not going to solve this one. Class, just go ahead and memorize it for now. If you want me to solve it, prove it, I can prove using a right triangle. Are you with me, class? Using a right triangle, we can prove this one. But let's go ahead and memorize for now so we can do our homework. So arc sine, derivative of arc sine is what?
You
Always square root of 1 minus what? Whatever that is, you square that. And then what do you do? Whatever that is, you do what? Take a derivative of that. That is your arc sine. But this is easy. The reason is arc sine, arctangent, secant. When you memorize this one, the other one is what? Exactly same thing, but you put what? Negative sign. So you only memorizing what? One of the main ones, sine, cosine, and sine, tangent, and what? Secant. So arc secant is u prime over square root of 1 minus u squared. What's the tangent? Arctangent is what? U prime over what? 1 plus u squared. So you will not be confused because they're all different format. Arcsine has only square root of this, and arctangent has what? Arctangent does not have a square root. It's just 1 plus what? U squared. Look at the arcsecant. They are similar to arcsine, but they're what? Inverse 1 and u, right? Look at this. This is u squared minus what? 1, isn't it? So you will not be confused with those arcsine because their format is different. Sine is what? 1 minus u squared. Arcsecant is what? U squared minus 1. Not just that. What do you also have? Absolute value of u in the front. That's why you will not be confused with arcsine because they're distinctively different. Did you see everybody? They're all different. They're distinctively different, so you will not be confused. When you see this format, you know how to apply. All right, so 1 plus u squared is u prime. Next one is what? U prime, and then what? Absolute value of u, and then what? Square root of u squared minus 1. So you need to know arcsine, arctangent, arcsecant. But the other one is just the what? Negative in the front. Arccosine is same as arcsine, but what do you put? Negative. Arcotangent, same as arctangent, just put what? Negative. Arccosecant, same as arcsecant, what do you put? Negative in the front. Is everybody with me? Did you memorize it? Square root of 1 minus u squared. The other one is what? 1 plus u squared. What's the other one? Absolute value, and then what? Square root of u squared minus 1. Is everybody with me? Okay. So let's take a derivative of this. Well, it's already did it because it's so simple. What does it say? It's arcsine, then you're going to do what? Square root of 1 minus what? U squared. U is my what? That's my u, right? U is 2x. U prime is what? 2. So u squared which is 4x squared, u prime is 2. You're done. Do you like it so far?
Yes.
Yes. Next one. My u is what? 3x. U prime is what? 3. It's arcade, it's a 1 plus u squared. So 9x squared. Everybody see this is the same as 3x times 3x, right? Okay. So that's what 9x squared over 3. All right, this case my u is what? Square root of x. Can I rewrite x to the 1/2? So my u prime. By the way, when you take your exam, when you do your homework, please write down u and u primes and all that. So you will not be confused. And when I do grade your paper, I need to see your work. Okay, some of you guys, somehow you have answers, but I don't see any work. So I have a feeling you memorized that question because that question is exactly the same as your homework problem. If you do that, I cannot give you full credit. Your answer has to show what your work has to show. Remember, your executive said, in order to receive full credit, what you have to do? Show your work. All right. So is everybody with me? What's this one? 1/2 x to the what? Negative 1/2. All right. So, does everybody see 1/2 x to negative 1/2? That's my u prime. Are you following me? And then what does the formula say? Since it's arc sine, square root of what? 1 minus what? X. Everybody see this is only x. Why? Square root of x squared is what? It's just to x. Next. This goes to denominator and this goes to denominator. Is everybody with me? It's 1/2. So 2 needs to go denominator. This needs to go denominator. That's why you have that as your answer.
Okay.
Is everybody with me so far so good? You're not getting it? Look at this problem. This is the same as what? Is everybody with me? So I'll put this one right here. Are you following me now? Okay. You want me to erase? It's good? All right. What this person do? I mean, what this did what? You simply multiply inside. That's what it does.
Oh, okay. I see.
But don't worry about doing this. You don't have to do this one. This is great, but I don't expect you to do that. If you stop it right here, if you stop it right here, it's fine. So this is just fine. All right? This is great. I may even give you half credit for this, okay? Because you remember to do what? Multiply this inside. That's why you have x, and this become a what? X squared. But I don't expect you to do it, but if you do it, I'll give you credit, half credit. All right, arcsecant. Let's write down my u. What's my u? E to the 2x. What's my u prime? E to the 2x times what? 2 in the front. So the formula says absolute value. By the way, this does not put any absolute value. Why? E to the 2x is always positive. Since it's always positive, I didn't put this. But if I want to, yes, I can put it. Like this. I don't have to put x squared as absolute value. Why not? It's always positive, so I don't need to put it. I can just simply put what? X squared. Same thing. E to the 2x is always positive, so I don't have to put absolute value. But the formula says absolute value, and then what? U squared, which is e to the 2x squared minus 1. U prime, which is that. Then everybody see this and that cancel out. That give you what? E to the what? 2 times 2, 4x minus 1. Is everybody following me? So far, so good? Okay. This has been easy for us right now because we didn't prove anything. We simply what? Using it. Such much easier. Okay, absolute value sign is not necessary because what? E to the 2x is what? Always positive. All right, review of a basic differentiation rule. So this one, we're just going over everything we so far learned. Okay, we know about algebraic functions like polynomial, rational functions, and functions involve radicals. Those are all algebraic functions. Then we learn in chapter 5 as well. Transcendental functions, which is what? Logarithmic function, exponential function, trigonometry function, and then what? Inverse trigonometry function. So we learn. So chapter 5 is all about what? Transcendental functions. So this is all the review. Everything you learn from chapter 1 through 4. This is what you learned in chapter 5. And actually this one you learned it previously.